In the last video, we introduced the principle of conservation of energy, which says that energy cannot be created nor destroyed, just converted from one form to another. So these energy conversion questions, just have a look at a few examples of those. So if we start off with the first one, so we have kinetic energy and it's going to electrical energy, then that is a generator. Okay, so say like a hydroelectric dam, the water front has potential energy and it falls down the spillway. That spins turbines, which have magnets and coils of wire, which induces electrical current through those ones, and so that then it gets converted to electrical using a generator. So there's other ways we can do that too. So electrical energy now to sound energy, so some sort of speaker. Okay, so on your radio or stereo or whatever. Yeah, headphones. Chemical energy to kinetic energy. An engine is an example of that. We have light energy to electric energy, so your solar cells can do that. Heat energy to kinetic energy, so a thermal generator. Alright, I'll chuck a couple in here, but you can look up as many as you want. So if we have gravitational potential energy and to electrical energy, I kind of gave you a hint before, electrical energy, and maybe electrical energy to light and sound. So feel free to have a go at those or make up your own. Describe the energy conversions which take place during the following events. Okay, so let's have a stone. Let's draw a little diagram. So I have a stone here, which is dropped from some sort of height, and then it falls towards the ground. It's falling towards the ground, and then lastly it hits the ground and stops. I'm going to get a different little colour here. Let's go red. Okay, so we have here potential energy of the stone, and then that gets converted to kinetic energy as it starts to move. It's got kinetic energy, and then when it hits the ground, what happens? Well, we hear it, don't we? So we hear sound like that, and also it heats up the surface. Okay, so what actually is heat and sound? So all heat is the vibration of particles. So that's why I've kind of drawn those wiggly little lines there. So what heat is, if you like rub your arm or your leg, you'll feel yourself heating up. So you're basically you're using your chemical energy from your body, and you're creating friction. And what's that's actually doing? It's actually moving your particles faster. So that's what you're feeling when you're feeling heat. So if you feel heat through the sun, basically the sun is making your body particles move faster. Okay, so what is sound? Sound is the vibration of air particles. So that's why I've drawn these little lines in here. So it's actually vibrating the air. And it said in our notes before that sound actually ends up being heat as well, because it's just a movement of particles. So sound is a sort of a form of that as well. So yeah, so that's what heat and sound is. If you're wondering, you shouldn't have to explain it to that level in this course. So a boy jumps from a height onto a trampoline and then rebounds upwards to a height somewhat less than its initial height. I'm not going to do any more. I won't bother doing any more diagrams, but what we have first is the boy jumps from a height. So let's say he's got gravitational potential energy. Then that gets converted to kinetic energy as he falls. And then it's elastic potential energy, or elastic energy in the springs. It gets stored in the springs. And because it says here, rebounds up to a height somewhat less, we can say that at this point here, some of the kinetic energy was lost to heat and sound. And if you've jumped on a trampoline before, you've probably heard the springs make noise, and that's some energy getting lost. And there's probably some heat between your feet and the mat. And then as you go back up, that elastic energy goes back into kinetic energy, and then when you get to the apex or the peak, then you've got your maximum potential energy again. And sometimes I say it as PE, sometimes I say it GPE. I'll probably, just go between one or the other. Alright. So, a battery powers a torch bulb. So we have chemical energy in the battery. It gets converted to electrical energy. And then that gets turned into light. And of course there's some heat in there as well. A car is driven at constant speed by a petrol engine. Okay, so we have chemical in the fuel, goes to mechanical and kinetic, and of course heat, sound. A parachutist jumps from a balloon. Okay. He initially accelerates, but then travels at terminal velocity for a while before reaching the ground. So again, it's just gravitational potential energy, kinetic energy, and then comes to rest. So heat, sound, just like our stone. A hydropower plant produces electrical energy for the power grid. So I might just draw. I might as well draw something. Okay, let's go blue. So we've got up the top here, got a bunch of water. Up the top and down the bottom. Okay, so there's a. Let me get. I should draw that all in grey, shouldn't I? So we've got all this water stored in our dam here, and we've got a little. So we've got, this is going to be GPE, gravitational potential energy. That's stored in our water. Okay, so then as the dam is opened, so it's open now. So we've got all this water, and it starts to go rushing down the spillway. So that water is getting converted into kinetic energy. So gravitational potential energy up here, it's gone into kinetic energy, and then that spins the turbines down the bottom. So I'm not going to try and draw the turbines. So it goes to mechanical energy, and then that goes to electrical. Sometimes I skip the mechanical one and just go straight from kinetic energy to electrical energy. It shouldn't matter too much. So a nuclear power plant station produces electrical energy for a power grid. What kind of radioactive colour do we want? Green? No, we've got yellow. So we've got nuclear energy. Goes to, and it actually heats up the water. So we've got control rods in, heats water. So then that produces steam. It produces steam, which spins turbines. Steam spins turbines. So what's that then? I guess that's mechanical / kinetic. So we've got that happens, and then that gets converted to electrical. Okay, and yeah, if you're interested in that, you can look up some videos on that too.